guys. So I welcome you to the lecture series on digital image processing. Myself, Dr. Dibya, presenting you today's topic on color space. So, guys, color space is a very important topic with respect to color image processing. And believe me, without color spaces, we can't deal with the image processing operations with respect to color images. So the basic concepts you have to know about the color space, I'm going to present here today in this class. So first of all, what is color space? A color space is actually a specific organization of colors which in combination with physical device profiling allows us for reproducible representation of colors in both digital and analog representation. And this color space is a special tool for understanding the color capabilities of a particular device or digital file. So, in just one line, you have to note down that color space is the abstract mathematical model that helps you to specifically organize the colors with respect to the physical device you are using to present them. Now, according to the trichromatic theory, the three separate lights, that is red, green, and blue, can match any visible color based on the eye's use of three color sensitive sensors. And about this red color, green color, and blue colors, I have illustrated much more about this and about their mathematical backgrounds, means how to produce them and how they affect our eyes. Okay, so it is the way that most computer color spaces operate using three parameters, means these three parameters to define a color. So a color can be described using three coordinates or parameters which describe the position of the color within the color space being used. That's our color space and its relation with respect to color. Now, next thing we have to study that what are the different types of color spaces. As you all know that in normal cases, we use RGB as our default color space. But if RGB is there, then why we need other different color spaces? And that is the question taking our mind. So, if RGB color space is the default one, then why others? This is because different color spaces present color information in different ways that make certain calculations more convenient and also provide a way to identify colors that is more intuitive. As for example, RGB color space defines a color as the percentage of red, green, and blue hues mixed together. Okay, you all know about that. But others describe colors by their hue, saturation, and luminance or intensity. So that's why we need other color spaces, because in case of RGB color spaces, hues are mixed with every channel, that is red, green, and blue. And a color is represented with the combination of these three RGB values. But we need some color spaces which have different hue, saturation, and luminance or intensity channels. Coming to the classification, we have device dependent color space and device independent color space. So this question is also asked that what is device dependent color space and what is device independent color space. So let's discuss them. A device dependent color space is a color space where the color produced depends on both the parameters used and on the equipment used for display. For example, RGB is a device dependent color space. So if you try to specify the same RGB values on two different workstations or two different devices, the color produced will be visually different if viewed on side-by-side screens. So you may get different outputs for the same RGB values in different workstations. So it is totally depend on the device used for presenting that color. So that's why this is known as device dependent color space, and it is a very means limitation, critical limitations with respect to device dependent color space. So you may not get the same result on different devices. But a device independent color space is the one where a set of parameters will produce the same color on whatever the equipment they are being used. Now, in case of device independent color spaces, the dependency on device vanishes here, because it actually doesn't matter which device you are going to use, the resultant color will be same, whatever the equipment you are using. As for example, LAB, that is L star, A star, B star, is a more frequently used device independent color space. So guys, I hope that's sufficient for today's lecture. So I have described what is color space in this lecture as part of trichromatic theory, how this is related, means how color space is related to color. And then we have seen different type of color spaces exist, like device dependent and device independent. And if RGB is the default color space, then why we need other? That question is also being described or illustrated here in this lecture. So coming to today's question, and today's first question is that how color space is related to color with respect to trichromatic theory. Second question is that define color space and define device dependent and device independent color space. And third question is that if RGB is the default color space, then why we need other different color spaces? Well, that's all for today. Thank you. Bye-bye.